So hello everyone, let us solve another LeetCode problem, and the problem name is minimum pair removal to sort array part 2. So we have already discussed the part 1 of this problem, so I will attach the link in the top right corner so you can watch that part 1 video as well. So the difference between the part 2 and the part 1 problem is just on the constraints. The problem statement is exactly similar. So only difference comes in the constraints, but still we can just read the entire question and understand if someone is new and just watching this video out. So let us read the problem first. So given an array nums, you can perform the following operations any number of times. So select the adjacent pair with the minimum sum in nums. If such pairs are multiple, then choose the leftmost pair. Okay, then replace the pair with their sum. In the end, return the minimum number of operations needed to make the array non-decreasing. And then they have said what is non-decreasing, so they have just given the definition of that. Now, what the question is saying that you are given some array nums which has some elements. Now, this array might be not in non-decreasing order. So you need to convert this array into non-decreasing order. How you will convert it into non-decreasing order? There will be pairs, there will be n minus 1 pairs which will have some sum, right? There will be n minus 1 pairs which will have some sum. Now within this n minus 1 pairs, you need to select the pair which has the minimum sum. Okay, you need to select the pair with the minimum sum. So let's say we selected a pair which is 2, 3. Now you need to replace this entire pair with its sum. So let's say 2, 3 was here. So we replace this with single element, that is 5. Now you will again need to check whether this array is non-decreasing or not. Then you need to again apply operation if it was not non-decreasing, and so on and so forth. This will go on up till your array becomes non-decreasing. So this is what the question is saying, and the approach I told you just now, it is a brute force approach that we applied in part 1. So this was the approach that we applied in part 1, but we cannot apply the brute force approach in this part 2. Why? Let me just show you how the constraints differ. So in part 2 and part 1, there is difference in the constraints. So in part 2, what is the constraints? So n, that is size of nums, here can go as max as 1e5 or 10 raised to the power 5, and nums of I value can go as max as 1e9 or 10 raised to the power 9. Also it can go in negative as well, minus 1e9. In part 1, the constraints were different. In part 1, the n value can go up to 1000, and the nums of I value can go as max as not 1000, it was actually 50. So it can go up to 50, and nums of I value can go as max as 1000, and it can go in negative as well, so it can go up to minus 1000. So these were the difference between the constraints. In the part 1, we applied the brute force which has the time complexity of O of n square. Now can we apply the same brute force approach when we have n equal to 10 raised to the power 5? No, it will give us the total time complexity of 10 raised to the power 10, which will surely give us the time limit exceeded. So we cannot apply the brute force approach in this part 2. Okay, now if we cannot apply the brute force, how will we optimize this? Because in this we don't need to decide any algorithm, right? Like which pair we will choose, what if there are ties, then which pair we will choose. No, the question has already given the instruction how do you choose the pairs and how do you need to perform the operations. So we don't have control on how do we perform the operations. So we cannot say that okay, this is how we'll be performing the operation. We will generate our own algorithm. Okay, this is how we will choose the pair. This is how we will choose if there is a tie between some sum. No, the question has already provided us the information or the how we need to apply the operations. So we don't need to make our own algorithm. So here the algorithm part we cannot optimize it. So how we can optimize it? So in these situations where you do not have the control and we still need to optimize this, you think in terms of data structures, like how do we optimize the lookups? How do we optimize by not getting the minimum sum by iterating over the entire array each and every time? So you start thinking in some data structure way, like which data structures I will use, how I will manage the pairs in what data structure, such that I like the time complexity of doing some operations is minimized, is either becomes very less or it becomes just constant. So you start thinking in terms of data structures. So first of all, to understand what data structures we need, first we need to understand what all problems were there in the brute force approach, because then only we will see, okay, this is the problem and how we can optimize this problem with the help of some data structure. So first of all, let us understand what is the problem with the brute force approach. So first of all, let us discuss what all problems exist with the brute force approach. So first of all, the first problem is that we are scanning the entire array for the minimum sum. So for the minimum sum, you are searching the entire array. Okay, if this pair is the minimum, if this pair is the minimum, if this pair is the minimum, if this pair is the minimum. No, you don't need to do that. Even if you merge a pair into their sum, the single element, then you put this into the array, then again you search like whether this pair is minimum, whether this pair is minimum, what pair is the minimum, so on and so forth. So we don't need to do that. Now what is the solution? We will discuss the solution as well, but first let us understand what all problems exist. Now what is the second problem? The second problem is that we are shifting all elements after the merge. Now there you see that we were using dot erase method of nums.begin plus idx plus 1. So what this will do, this will just iterate over the array and make that will delete this particular index and shift those the elements to the right towards that empty position. So it will shift all the elements after the merge. Now this will take O of n time complexity in itself. Now obviously if this gives us the O of n time complexity, we don't want that. So this is the second problem, and how we will find the solution for that, we will see. First of all, let us discuss all the problems. So what is the next problem? The next problem is that rechecking the whole array order again and again after performing operation. So whenever you apply operation, whenever you take the minimum sum pair, you merge that, right? You merge that. Now after merging, you again check, like after performing this operation, did my array become non-decreasing or not? If it didn't become non-decreasing, you apply the operation again. You take the next minimum pair sum and then you again merge. Then you again check whether applying this operation made my entire array non-decreasing or not. So after each and every operation, you are again and again iterating over the entire array, which will take O of n time complexity. And obviously we don't need that. We don't need to do these repeated things, and we don't need to iterate over the entire array. Now what is the solution? So let us see what is the solution for each and every problem. So first of all, we were checking the entire array for the minimum sum. Now if the problem requires you to find minimum sum each and every time, what data structures come to your mind? It can be either set or it can be either min heap, because the min heap always keeps minimum element at top. Top element is always minimum. So you think either min heap or set. In this case you can also use min heap, that will also work fine, but I have used set because set first element will always be the minimum element. So either of the data structures can be useful. I'll be going with the set approach, but you can also use the min heap approach. There is nothing wrong with the min heap approach. But yeah, we were checking entire array for the minimum sum again and again. No, you don't need to check the entire array. Let's say you have this set of sum like this. The minimum sum is currently 8, then 10, then 12. Now you applied some operation. Let's say the 8 was removed from the set. Now let's say the minimum sum is, let's say after merging it, the 8, the sum that the new adjacent sum you got is 11. So you again insert that into the set, and set will take care like what is the new minimum element. So set will automatically fit this 11 into the middle part. So this is the data structure which will help us find the minimum element always. You don't need to iterate over the entire array to get the minimum element. So this is the solution for the first problem. So stop checking the entire array for the minimum sum, just keep this set, because after all the only adjacent sum matters, right? Only the adjacent sum matters. Let's say what we were doing, we had some pairs, right? So we were computing this sum, we were checking what is the minimum. Now after doing some merge operation, you don't need to check the entire array. Those sum did not differ. If you merge this particular thing, if you merge the first pair, you don't need to check other pairs again for the minimum sum, because those pairs were not affected, their sum was not affected. Only one pair affected, that was the two elements that got merged. So now only the adjacent numbers matter, only the adjacent sum matters. So let's say we are taking some example 7, 6, 5, 4, 3. So I'm not considering about the minimum pair sum and all of that. I'm just taking one example just to show you what we are optimizing it actually. Now let's say these were the pairs that we have already computed the sum, and this was the pair with the minimum sum, right? Now you merge that and you got 7. Now you don't need to check for the minimum sum entire the array, because their sum won't affect, this sum will remain 13 only. The only difference comes in the sum is with the previous number, this number and this number, because now these two will become pair. So the only adjacent numbers matter, only the adjacent sum matters. So that's why we don't need to iterate over the entire array. We can just keep a set which will reduce our time complexity. So set is the data structure which we can use for this particular problem. Now what was the second problem? The second problem was that we were taking O of n time complexity to shift the elements. So stop shifting the elements like this. Stop using this dot erase method. We have some more optimal way to do that. We can use a linked list. Now obviously in the first case you won't get the idea of linked list, because in this kind of problem you don't think of linked list. The linked list problems are built in some different manner. They have already given us some linked list, or it like this problem involves a linked list or not. So you won't initially get the idea that we need to use linked list or not. I also didn't get the idea, but then I looked at the hint, and then they have discussed about the next and the previous element. So from that I got the idea of doubly linked list. So you can use the linked list, because why linked list? Because you shift the element. Let's say these are the numbers. Now you merge these pairs. Now you don't need to iterate over the entire array. No, you just need to make sure that this particular element doesn't point to this element. Instead this particular element should point to this element's next element. So you point this element to this, and you make sure that this particular element does not point to this element. This particular element should point to this element. So indirectly you see, if this is pointing to this element and this is pointing to this element no more exists in our path. So this is automatically removed. So we don't need to iterate over the entire array. We don't need to use dot erase. We just need to take care of the previous and next elements in order to erase or shift a particular element. So here also we only change the neighbors. So we don't need to iterate over the entire array. Just few elements to the right, or one element to the right and one element to the left will do the work. So we can use the linked list and stop shifting elements with the help of dot erase method. We can use linked list in order to do this in O of 1 time complexity. Now how we'll be using this set, how we'll be using the doubly linked list? So don't worry, I will just explain in few moments with the help of one proper example. But for now, just understand what was the problem and how we will find solution for that, because then dry running that with that particular idea will become a lot more easier. So these were the two solutions. And what was the last problem? The last problem was that we were checking the whole array after doing some operation. So this is pretty much simple. Just keep a count. Let's say you are keeping count of how many bad pairs are there. Bad pairs. Let's say there were 3 bad pairs. Now after shifting, after merging, and after shifting all of that operations, after performing one operations, you don't need to iterate over the entire array, because let's say this was the array and you merge these 2 pairs. Now this will become one entire sum. This was some number x and this was some number y. Now again, you don't need to check the entire array, because the only adjacent elements matter, because the new pair form will be with s and x, the new pair form will be with s and y. So only few comparisons matter, or in more specific way, only 3 comparisons matter to check whether the array is non-decreasing or not after performing some operations. The current and next are getting merged. So if they are getting merged, they will become single entity. So you need to compare it with the previous element and the next element. So you can see only 3 comparisons we need to do. Obviously first we are merging this one, so obviously current and next will be involved in the pair sum. After merging, we need to match this pair sum with this, compare with this next element, and we need to compare this sum with the previous element, because now these will make pairs. Now what will happen? These will make pairs. So we can count here only whether after merging we have some increment in the bad pairs, or we have some decrement in bad pairs, or the bad pairs remain same. So you don't need to iterate over the entire array. Just comparison with the neighbors will give us the hint, or we can, with the help of that only, we can keep track how many bad pairs are exist. So with the help of one variable count, we can just keep track of how many bad pairs are there with us. And when the bad pairs become 0, we stop our iteration and we return the answer. And again, we just need to apply the operations as the question has said. So whatever answer we get after the bad pairs is 0, we will get that minimum only, because we have just applied what the question has said. We don't have our own logic to choose elements or anything like that. Now let us understand with the help of one dry run example, then you will understand in more better way how we are using these data structures, where we are using it, and what actually at what point they are actually optimizing it. So this is the example that I have taken. Now I will dry run on this example. I will try to dry run on one of the operations, like how this operation is happening, how do we get the minimum sum, how do we merge that, how do we use linked list and all that. So with one operation I will show you the dry run, because if I show you the dry run for each and every operations, this will become very long. But I guarantee that with the explanation of this one operation only, you will be able to understand okay how the things are actually working. So I will dry run on one of the operations and then you will understand what is happening. So first of all, this is the nums array that we have 10, 6, 5, 3, 7. Now first is that we need to count how many bad pairs exist, because we need to make bad pairs equal to 0. So we first compare adjacent pairs. So this is one bad pair because this 10 is greater than 6. So this is not in non-decreasing. So we count our bad pairs till now as 1. So 10, 6 is one bad pair. Then 6, 5 is also a bad pair, because again this is not in non-decreasing order. So we count this pair as bad pair. So our bad pair count become 2. Now we again have this bad pair 5, 3, because this is again not in non-decreasing order. So our bad pair count becomes 3. So in total we have 3 bad pairs that we need to make 0. Now while applying operations, this can become more, this can become less, but overall we need to make this 0. So how will we do that? So first of all, we will be using a doubly linked list, which will, now this is not actually, we are not actually creating the doubly linked list. We are maintaining 2 arrays, previous and next, which will act as a doubly linked list. So we are not actually creating these kind of nodes and doing that. No, we are just making two arrays, previous and next, which will tell us for this particular number what is the previous number and what is the next number. So these two pairs will act as a doubly linked list. So in our simulation it would look like we are actually iterating on a doubly linked list, but actually we are doing with the help of these two arrays. So this previous array will keep track of the previous index of the current element. So this is the 0th index, right? So its previous will be -1. So we are storing -1. This is the first index. So its previous element would be at the 0th index. So we are giving 0. So on and so forth. For 2, 1 will be the previous index. For 3, 2 will be the previous index. For 4, 3 will be the previous index. Similarly, next is going as like this. So for 0, next will keep track of the what is the next index. So for 0, 1 will be the next index. For 1, 2 will be the next index. For 2, 3 will be the next index. For 3, 4 will be the next index, and for 4, 5 will be the next index. Now we will also keep check wherever like for this -1 and 5, because these actually do not exist in our array. So we will keep check whether our previous is currently greater than equal to 0 or not, or our next is less than n or not. So we will keep check. We will keep check of that as well. So yeah, this is a kind of doubly linked list that we create. Now what we need to do first in our operation, we need to find the minimum pair sum, and we need to do the operation of merging and what all, shifting and all that. So we will keep track of set. So we will use a set in order to get the minimum adjacent pair sum, you can say. So how we are storing the minimum sum in the set? So first will be the sum value, and the second will be the index of the element of the starting pair. So let's say this is the pair 2, 3. This comes at 0th index, this comes at first index. So idx will be the 2. So whatever the pair is, the first element will be actually the index, because the next index will actually get removed. So the pair's first element's index will be storing here, and since we are storing in the set, so this will be in the sorting order. So we will always get the minimum sum initially, and also we are storing the index. So whatever is the leftmost minimum pair sum, we will get that only in case of tie. So if there were two sum which has 8, let's say 8,2 and 8,3. So there were two pairs, let's say, which has the minimum sum as 8, starting from index 2 and starting from index 3. So set will keep track of the choosing leftmost, because set will again give us the 8,2 as the minimum pair, because these are getting tied. So it will compare on the next value 2, 3. So 2 is lesser than 3. So by default, if there is a tie in sum, we will get the leftmost element only. So first minimum pair sum is 8, 2. So 8 is the sum, 2 is the starting index, or 2 is the first index of the pair. So now we need to apply the operation. Now how will we actually apply the operation? Now the main logic comes here. So I have drawn this nums in terms of doubly linked list, so that it is much more easier to visualize how the operations are working. So this is the 0th index, this is the first index, this is the second index, this is the third index, and this is the fourth index. Now what is the sum? What is the minimum sum? Minimum sum was 8 with starting with index 2. So our pair is 2, 3, right? Obviously the pair is 2, 3. So the minimum sum pair is 2, 3. 2 has the value 5 and 3 has the value 3. Its next element will be the index 4 and its value is 7. Its previous index is 1 and its value is 6. So we are getting this previous and next with the help of the next and previous array that we created. So why we are keeping track of the previous and next and all that? Because we have discussed in the solution, only neighbors or the adjacent pair, adjacent element matter to us, not the entire array or the entire list. So first of all, what we need to do, this is the current pair 2, 8, which has the sum 8 and starting with index 2. So first of all, we need to check whether this is a bad pair or not. So we will check whether a of current index is greater than a of next index is or not. So current index is 2, which has the value 5. So a of 2 nothing but 5, and a of next index is 3. next index is 3 and its value is 3. So a of next is 3. So 5 is greater than 3, right? 5 is greater than 3. So this is a bad pair. This is a bad pair. Now we are merging this bad pair. So if we merge this bad pair, this will not be a pair anymore. This will be a single element with value 8. So this will not be a bad pair anymore. So we need to remove this particular bad pair from our account, because this is no more a bad pair after merging. So we have currently 5 comma 3. After merging it will become something like this. So now this 5 comma 3 not exist as a bad pair, because this become a single entity. Now it might happen that this 8 will become a bad pair with its previous or next. That is a different thing. But for now this particular number is not a bad pair. So we will decrement our bad pair count. So okay, remove this particular 5 comma 3 or 8 comma 2 from our bad pair account, because we are merging this and this is no more a bad pair. Okay, so what will we do next? We need to check whether this new entity, so we have 5 comma 3, so we merged it, we got 8 as the element. Now we need to check whether this 8 becomes a bad pair with this previous element or its next element or not, because obviously if we merge something, what we were doing in the brute force, we were again iterating over the entire array and checking what are the bad pairs, what is the minimum pair sum. We don't need to iterate over the entire array, only the neighbors matter, right? We have only discussed in the solution of the brute force approach, like we just need to compare with the neighboring elements, because we have seen only 3 comparison matter and all of that. So we just need to compare it with the previous element and the next element. So 8 is the merged element. So we will check whether this previous and current, or the previous and the entity that merged become a bad pair or not. Whether this merged entity and next element becomes a bad pair or not. So we need to check that. So we merged 5 comma 3 and it became 8. So the previous element is 6. So we will compare it with the previous one. So 6 here is greater than 8. Now how will we check whether this is a bad pair or not? That is simple, but we need to also keep track that whether this 6 was making a bad pair with the previous element before merging with 5 or not, because you see 6 is greater than 5. So this was a bad pair. This was a bad pair, right? So after merging, this is not a bad pair. So we need to remove this 6 comma 5 also from our bad pair. So what I am saying, whether a comma previous index was less than a comma current index or not. So before merging, so this is the case before merging. So before merge. So before merge, these were a bad pair. This was a bad pair if this was a bad pair, and after merging, this is not a bad pair. So 6 is greater than 8. This is after merge. So this is not bad pair anymore. So initially we had 6 comma 5, but we have now 6 comma 8. So this is not a bad pair, but this was a bad pair, but this 5 doesn't exist. So we need to remove this also from our bad pair account. So whether the previous a of previous, that was 6, and a of current, that is 5. So yes, this was a bad pair previously, but now a of previous is 6 and current number will be the merged entity. So what will be the merged entity? The sum of current and the next element. So current is 5 and next is 3. So this becomes 8. So 6 is greater than 8. So this is not bad. So previously it was bad, but now it is not bad. So we need to remove this 6 comma 5 from our bad pair account. So we are just doing count minus minus. So I hope you understand this part. So we are just comparing it with the previous element, and we will now do the same with the next element. So what is the next element? So next element is 7. So we will do the same thing. So 3 is less than 7. So before merging, 3 was the element which were making pair with this 7, or 3 comma 7 or 3 comma 4, whatever, on the basis of index or on the basis of value. So previously you see this is not bad, right? This is not bad, but after we merged, this became 8, this became 8. Now this become bad. Now this thing become bad. Now this 8 is greater than 7, because it can happen vice versa. Previously it was bad, but now this is not bad. Previously it was not bad, but now this is bad. So same scenario could have happened when we are checking previous also. I have just shown one scenario, but while we are discussing the code, we will check both the scenarios. I am just showing the unique scenarios that we have till now. So this check will also happen in the previous part also, and the previous part check that we had, this will happen in the next also. So both the things we will check, whether this was previously bad and now it is not bad, or previously it was not bad and now it is bad. So in both previous and next we will check that, but I am just showing you the unique things. So this is what we are doing. So previously this was not a bad pair, but now after merging this became a bad pair. So we need to increment our count. So we need to increment the bad pair count, right? Because obviously if we are merging, there will be changes coming inside the array. So that's why we are using a linked list. We don't need to iterate over the entire array and find the new minimums and all of that, or new pairs and all of that. So that's why we are just comparing with the previous element and the next element, because changes will happen in the previous and next only, not on the entire array. So this is the case where it was not bad previously and now it is bad. After merging it became bad. So these scenario will be checked in both previous also and next also. And in the previous part, what we check, it was bad previously and it was not bad after merging. So this case is also checked here in the next part, but for now I am just showing this part, because in this it is not going to actually count into our account. So in the code we will check both of the scenario in both of the cases, previous and next, but for now I am just showing you the unique cases. So before merging it was not a bad pair, but after merging it became a bad pair. So how do we check this particular thing? So a of next comma next, so this is the fourth index, so a of 4, so a of 4 is 7. So a of 7, was this previously greater than equal to a of next? A of next was what? 3. Next index is 3. So yes, this was in non-decreasing order previously, but now 7 is less than a of current index. Current index is current index is 2, so a of 2 is 5, because we merged current and next. So a of next is 3 and the next index was 3 obviously. So after merging these two will be combined into the sum, so now it will become 8. So now this 7 is less than 8, so now this became a bad pair. So we will increment our count. So now this became bad, so do count plus plus. So this is the scenario that we will be checking. So what scenario we are checking? In the previous also we will check, and in the next also we will check the same thing, whether it was previously not bad and it became bad, or we will check whether this was previously bad and now it became not bad. Similarly we will check here, previously it was not bad and it became bad, but also the other scenario can be previously it was bad and now it became not bad. So we will check these two scenarios in both next part and the previous part, both the scenarios. In the explanation part I have only taken one scenarios, because the other scenario was not taking into our account. But yeah, in the code we need to check both, because that is when only we will be able to match our count with the actual logic. So that's why. Now we have maintained the count and all of that, but we have actually seen that we have 5,3 and we have taken this sum and all of that. But how do we actually merge that? Because till now we have not we have actually not merged that pair. We have just taken the sum and previously compared with the previous element and next element, and we have actually just taken care of the bad pairs till now. We have not actually updated our previous index and next index, because after merging our previous index and next index will also affect with the current index. So now we will merge that. Now we will see how do we merge that. So first of all, this 5,2 is no more exists from our set, so we can remove this from our set, because now 8 is the new pair sum that we have. So first thing is what we need to do, erase this current pair 2, 3 or 8, 2 from the set. So erase it from the set. So now what we need to do, now if we are merging this current entity, so it will affect the previous element also, right? Because the previous element was making a sum with the merged entity first element. So previously what can happen, like sum in the set we are storing sum comma index, right? Sum comma index. So for this previous index the sum would be different. The sum will change now because previously the previous index was making the sum with this 5. So previously 6 5. So 11 whatever this index is 1. So previously this would exist in our set, but this 11 will not exist with this previous index anymore, because now this is 6 but this is actually 5, not 5, this is actually 8. So this sum will change, for this index. So we will insert this index, previous index again with this new sum. So the new sum is what? New sum is 14. So we need to do this operations. So what we will do, so first of all we will erase the previous index pair from our set and insert the new one for the previous index. So insert new one for the previous index. So how will we insert new one? Because erase is simple, just find the pair sum comma previous index. But insert, how will we do? So now the new pair sum will be what? Obviously the previous index will contribute to our sum, but the new pair sum will also contribute. So what was the new pair sum? The pair sum was nothing but the current index plus next index. So the new sum or the new pair sum for this previous index will become a of previous index plus a of current index, a of next index. This a of current index plus a of next index is actually merged into one entity. So this is now a one entity for this previous index. So previous index plus the new entity will be stored as the new sum for this previous index. So now our set would look something like this, 14, 1 or whatever the value is. So this is what we are doing. Now we will do the same thing for the next one. So previously it was 1, 2, 3, 4. So we have sorted this for the previous index. So for the previous index, now the new entity becomes 2, 3. Now we need to update for this new entity as well, because previously this 3 was making pair with 4. Now this new entity, this current index, current IDX will make pair with this next element. So we are merging. So we are merging this 2, 3. So this 3 will no more exist. Only 2 index will exist with the combined sum. So we need to update this sum for the current index with this next index. So what we are doing? So erase next index from the set. Erase the next index from the set. Erase the next index. Erase this 3 from the set, because 3 is no more existing. This is combined with the 2. So only 2 will exist. So now we need to update this for the current index. So now we will insert new for the current index, because new index is merged with the current index. So what we are doing? We are inserting in this set for a of next IDX plus a of next IDX with the current IDX. So what we are doing? So 1, 2, 3 and 4 was there. Now this is merged. So this sum will be what? Current, a of current plus a of next. Now we need to take sum with this 4 also, and this 4 is what? Next element. So whatever this next element is, its next is what this next is. So we need to take care this whole sum into our account. Current index, current plus next. This is one entity, and we need to pair it with the next. So we will take this into our account. So this is first element and this is second element of our pair. So we are actually counting this as a pair. So what we will do? The sum will be what? A of next IDX plus a of next IDX and a of current IDX. So this element is now a single element because they are merged, and the pair is nothing but this current index comma this next IDX, and we are storing this sum for this current IDX. So we are just inserting this current IDX with this new sum, because the previous one changed because due to merging. So this is how we are doing for the merge part. Now we need to also update the next and previous pointers as well, because after merging the pointers will change. Then only we can say that okay, we have shifted the elements. So how will we do? So previous of next IDX will become the current IDX. So let me just show you what I am saying. So it was 1, 2, 3 and 4. So previous of next. So this is the next is previous was initially this. Now we need to make it to this because this 3 is no more existing. So this is what we are doing. So previous of next IDX will become the current index, and next of current IDX. So current is this. Its next was initially 3. So now we need to make this 4. So we are doing next of current IDX should be next IDX. So this is what we are doing. Now also we need to take care of one thing, that okay, we have actually merged the operations, we have actually done the merging, but in the original array this 5,3 still exists. This 5,3 still exists. These are still unique elements. So what we can do? We need to actually merge. So this 5 should not exist. This 5 should be actually holding the value 8, which is the combined sum value. So what we are doing? A of current IDX should be now become A of current IDX plus next IDX, because these are merged. So this will no more be 5, this will become 8. So that when we process it further, we don't mismatch it with the previous 5 value, because now for someone this 5 will not exist as its next or previous element. For this 7, this 5 will not exist as the previous element. This 8 will exist as the previous element. So that's why we need to update in the original array as well. So A of current index plus A of next index will is what we will update the value for this current index, because we merged it. So for the current index, this will be the sum. So we can say that after all this thing we have done, we have check what is the minimum sum, we have merged that, we have shifted the elements, we have moved the pointers and all of that. Now we have completed this one operation, so we can do answer plus plus. So this was one operation. So this is what we are doing actually in one operation. So I hope you understand this approach. I tried my best to explain, but even if you didn't understand, I highly recommend you to dry run on another example, or continue the dry run for the second and third operation as well. For this example you will get a better idea, but I hope I tried my best to make you understand this particular intuition or the dry run. So let us see the code now. Maybe with the code you might understand in more better way. So yeah, this is the code. First of all, I am declaring n as the num size, and I am declaring another array A, which will be of long, because we need to do sum, and the num's max element can be 189, so it can go out of the range of integer. So we need to declare again a vector of long, which will be consisting of the same elements but in long format, not in this integer format. So what we are doing, we are just inserting all the elements of num into our new array, the same nums, the same elements, just in the long format. Then we are declaring a set of pair of long, comma long, comma int. So this will be the sum, and this will be the starting pair index. So in a pair we have two index 1 and index 2. This will be the starting index that will be storing. We have already seen what we are doing. Now we will create a kind of doubly linked list with the help of this next and previous arrays. So this next will store the index of the next element, and this previous will store the index of the previous element. Initially the answer will store the 0, which is total number of operations that we have done till now, and this count is nothing but count of bad pairs. So now first of all we will be counting the total number of bad pairs, and we will be inserting each and every adjacent pair sum into our set, so that we can always get the minimum sum at the beginning. So if the A of I is greater than A of I plus 1, that means it is a bad pair, so increment your count, and just insert the adjacent pair with the first element as index, and first element as sum, and second element as the first index of the pair. Now what we are doing, now the things which we are doing that we have seen in the drawing explanation part. So do this until our bad pairs are greater than 0. If the bad pairs become 0, that means the array is non-decreasing, or the element remaining is only 1. So we can skip that, we can stop there. So what we are doing, first of all we are getting the current index, next index, previous index, and next. So the current index will be getting from the first element of the set. So first element, second part. So second part is actually storing the index of the current index. So because the first is nothing but storing the sum, and second is storing the index. So this is the current index. Next index will be what? The current index next part. So we will search in the next array for this current index. What will be the previous part? Previous will be nothing but current index previous. So we can just check in the previous for this current index. So this will give us the element which is previous to the current index. Now what will be the next element? So obviously it sounds obvious. We can consider next as our current index, and we can find this in our next array. So next array gives us the next index of the current element. So we can consider next index as the current element, and we can find what is next to the next element. So we will get next ID. Now what we are doing? We are first checking whether this current and next were previously bad pair or not, because we are now merging. So whether this a of current index is greater than a of next index or not. So if it was, that means it was a bad pair. So now we are merging it. So we need to remove this from a bad pair. So we are just doing count minus minus. Then we will check. First of all, the basic condition, so that we don't go out of bounds, whether this previous index is greater than 0 or not. Now we are checking whether this previously the current index, so the current and the previous were previously making a bad pair, but after merging it with the next, they are not bad pair anymore. So we are checking this condition. So whether previously these were making bad pair, but now they are not making bad pair. So this is the condition that we are seeing in the drawing explanation part. So previously they were bad, but now they are not bad. So decrement your count. Otherwise, it can happen vice versa. In the drawing explanation part, I have explained this scenario for the next part, but I have also said that this can happen in both scenarios, previous and next also. So we are checking whether this was not previously a bad pair. So previously it was not a bad pair, but after merging this became a bad pair. So we need to increment our count. Similarly, we will do this for the next element. So again we are checking the out of bound condition, and we are checking whether this previously was not a bad pair, but now it became a bad pair. This we have seen in the drawing explanation part. So increment your count. But it can happen vice versa also. Whether this was previously a bad pair, but now after merging this is not a bad pair anymore. So decrement your count. So this is what we are doing. I am not explaining in much detail now, because we have already, I think, explained a lot in the drawing explanation part. So I am just moving forward with the conditions and how the conditions and the flow is working. Now what we need to do? First of all, we need to erase this whatever 8,2 is from the set. So we need to remove this from a set, because this is no more a pair anymore. We have merged that. Now if we have merged that, so it will affect the previous index and the current index also, right? So first of all, we will handle the previous index. So previously the previous index was storing the sum as a of previous index and a of current index, but this current index is merged with the next index. So we need to update this for the previous index. So this previous index will store the new sum as previous index will remain as it is, but with this merged entity. So a of current index plus a of next index. Similarly, we will do this for the next and current index also, because for the next index we were storing next plus next sum. So this next is no more existing. This is merged with current index. So what we can do for this current index, we can update its sum as a of current index plus a of next index. This is merged with this next index, that is nothing but next. Now after that, we need to update the previous and next pointers as well, right? So we are updating the previous pointer as well. So next will now become current index. Previously the next was pointing to, its previous was pointing to next, but this next is no more existing. It became merged with the current index. So this will now point to current index. So previous of next will become current index. Same for the next pointer as well. So current index was previously next pointer would pointing to this next element, but now these are two entities that got merged. So for this current index, this next will no more exist. Its next will be nothing but next. So that is what we are doing. So for this current index, the next will be next index. So that is what we are doing. And also we need to update the inside our array. So this 5 comma 3 we have actually merged. So for this particular 5 we need to update it with their sum, which is 8. So for the current index, update in our original array with their sum. And we have actually performed this one operation. So just increment your answer by 1. You keep doing this operation until your bad pairs are greater than 0. In the end, when bad pairs become 0, just return the answer. So I hope you understand this solution. I tried my best to explain, but still if you have some doubt, you can ask in the comments. I will surely try to answer that as soon as possible. So you can comment your doubt if you have any, but I hope I have given my best in order to explain this particular solution. I know this is a hard problem. The intuition was also not very obvious. I know it was a hard problem. I actually tried my best to explain, and I hope you understand this solution as well. So thank you for watching.